Hey everybody, welcome into another exciting geometry class. Let me just first of all apologize for the poor video quality. I'm waiting on my new camera to show up and my other one is not working right now. So hang in there. We'll get the camera thing fixed up, but maybe it's better because you can't see me as well. Um, but anyways, let's go ahead and get started. What I'm going to do today here in class is we're on page 11 in your books, and I am going to be going over common angles. Common angles. Basically, we're going to define, discuss different types of angles, okay? And there's a lot of different types of angles. You might think that there's only, it's angles and angle, but there's actually a lot of different kinds of angles. So on in your book, page number 11, the first one is what's called a paragon. You'll see right here. I have it written down here for you. A paragon. Now, a paragon is an interesting thing. I actually have a better name for it and you're going to hear me what my name for it is in just a second. But a paragon. So if I put a point here, remember everything starts with a point. So every geometric shape always starts with a point. And if we come out from our point, I'll change the color here so you can see it a little bit better. This is a paragon. If I take my angle, my other line, and if you look in your book, basically the lines, the paragon says, when the angle makes a complete revolution, okay? A complete revolution. It goes all the way around back to where it started from. That's called a paragon. Now, here's my better name for a paragon. Let me show you what the better name for a paragon is. All right, the better name for a paragon is, oops, it's a little bit difficult to draw there around that point. I'll erase that point. Is a circle. Okay. So basically, if I take my paragon idea and I extend my line around, what I'm doing is drawing a circle. Okay, I'm drawing a circle. A paragon is a name for a circle, but it's naming it as an angle. I don't know if that makes sense to you. A circle is basically named for the outside part of it. Okay, the circumference around. Okay, but if I'm naming a circle, if I'm calling it a geometric shape based on its angle, okay, based on the angle right here, okay, I would call this the name for a circle when it's based on an angle. It's called a paragon. Um, it says in the book that a paragon is another name for a round angle, so you could also call it a round angle. To be honest with you, unless you're dealing in some form of geometry or something along those lines, you're going to call this a circle. Everybody calls this a circle, okay? But that's the technical name for it, and it is good to know different things, different technical names, because if you ever hear the word paragon, now you'll know, okay, that's a circle, but it's talking about the angle of the circle, not talking about the circle itself. Okay, straight angle. Straight angle. Some of these are like so like the concept is so easy, but when you're dealing with angles, it's a little different. Well, here's a straight angle. Straight angle again is super easy. It's a line, okay, and then we just put a point on the line. So here's the idea of a straight angle. The idea of a straight angle is that you have taken your line, your angle, and you've gone back to exactly the same spot that you started from, or you've created a straight line. Well, all straight angles always equal 180 degrees. So if I take and I put a protractor on that, I would see that it's um, this is 90 degrees. This one right here would be 90 degrees. And so if I added one right angle, 90 degrees, and added another right angle, 90 degrees, 90 plus 90 is 180. A straight angle always equals 180 degrees. Okay. So that's a straight angle. And you could put on the ends of these, you can obviously put your lines because those are rays. So you could turn that into a line going in the opposite direction. Now, what's the difference between a line and a straight angle? Well, really that right there, that is called the vertex. The point at which the angle bends or turns is called the vertex. So the difference between a line and a straight angle is that a straight angle has a vertex. Okay, again, here's what we're doing. Before we called a circle a paragon when it comes to angles, and here we're calling a straight line just a line or a straight line. We're calling it a straight angle based on the vertex, based on the idea of the angle. Okay. All right, the next thing that we come to is the adjacent angle. The adjacent angle. So again, we're always going to start with our point. And then we would have, coming out of that point, we would have our line or our ray. And then an adjacent angle is an angle who shares a common side. So here we have another one. And this is the adjacent angle, and it doesn't matter where it is. It can even be out here, can be down here, but the idea is that you have a third side here. And so we could label this, we could call this A, B, C, and D. So angle ABC is adjacent to angle CBA. Those are what's called adjacent angles. Okay. This is a super, super, super important concept in geometry. You're going to use this concept all the time. So an adjacent angle is an angle that shares a side. Very, very important. Think about a classroom that is sharing a wall with another classroom, or in your house you have maybe your bedroom. On the other side of your bedroom wall is the living room. On the other side of your bedroom wall is the kitchen. On the other side of the bedroom wall is a bathroom. Well, that wall that you share with the other room would be called an adjacent wall. An adjacent wall. The wall that shares between the two. So what is the adjacent side in this one right here? BC is the adjacent side. Okay, that is the adjacent side. AB would not be adjacent. DB would not be adjacent. The adjacent side is that BC right there in the middle. Okay. All right. The next term that we come to is the right angle. The right angle. So again, we always start with our point. Never forget that. Never forget that geometry always starts with a point. It's so vital to everything that we do in this book. You have to remember, I always start with a point. Okay. And so we start with our point, and then we'll go this way with this one. And then the right angle is always at 90 degrees or at a perfect square angle. Okay. And one way that we signify that, one way that we show that right there is we always put one of these things in here. Okay. When you see that little L right there, here's what that means. That means that is a right angle. Okay. That is a right angle. If you don't see that, it might be a right angle, it might not be a right angle. We would have to prove whether or not it's a right angle. And we can do that with some different things that we'll learn later. But if the book puts that there, then the book is telling you that is a right angle. And right angles are always 90 degrees. Right angles are always half of a straight angle. Another way to look at it, half of 180 is 90. So there you go. There's the right angle. The right angle. All right, perpendicular lines is next. Perpendicular lines. Now you might say, that's not an angle. It is an angle. Okay, so watch what happens. So if I have a line going here, and I have a line going here, If they form a T, an upside down T or a regular T, they could go, they could also go this way. Well, they don't really touch there. There we go. Then those are perpendicular lines. Lines that form, and here's the way to say it, lines that form right angles. Oops, those are right angles right there, both of them. So they form two right angles. Here's what perpendicular lines form. They form a right angle, a second right angle, and a straight angle. So that's what perpendicular lines are. And they can be in any direction they want to be. They could be here. They could be on that angle. That's fine. They still form two right angles. In other words, this is still a 90 and that's still a 90. Okay? So they can be in any direction, any angle that you want, but they have to form 90s. Okay? If they form 90s, they're perpendicular. What if they form 89 and 91? Not perpendicular. It's got to be 90 and 90. Let's see here. The next thing that we have is the acute angle. The acute angle. So we'll take and we'll put our point. We'll start there. And the acute angle looks like this. Basically anywhere between 0 or no angle and 90. Anywhere between here. It can't be 0 and it can't be 90. Okay, but anywhere between it. So anywhere from, we'll call it, it is less than 90. And obviously it's got to be greater than 0. Well, I wrote that backwards. Sorry about that. I'm going to edit that out so you'll never even see it. Okay, so the acute angle is anywhere from 0 all the way up to 90. It can't be more than 90, and it can't be less than 0. Okay, so it has to start at 0 and go to 90. It can't be 90 and it can't be 0. So it's got to be between 90 and 0. So anywhere in there is fine. We could say that as the angle is less than 90, or we could also say that it is greater than 0. Less than 90 or greater than 0. That's the acute angle. One way that I remember that is it's little, it's a small angle, and so things that are small, we usually say those are acute. And so that is acute angle. Okay, it's small, it's cute. So maybe that helps you, maybe it doesn't, maybe like, but anyways, that's the way I remember it. Obtuse. Obtuse. What's an obtuse angle look like? Well, again, we always start with our point. And we draw our line here. Change that color. An obtuse angle is between 90 and 180. Between 90 and 180. Okay? It's got to be bigger than 90, smaller than 180. So we'll put it right there. Okay? So there's our obtuse angle. So the obtuse angle has to be greater than 90 and it has to be less than 180. Greater than 90, less than 180. That's an obtuse. All right. And the last one, oh, there's two more. Reflex. Reflex. I'll be done in just a second. Reflex is basically the way that I would describe a reflex angle is I would say it's the back side of an acute angle. The back side of an acute angle. So the way that we would draw this is draw an acute angle, and here's the reflex. The reflex is the back side of it. Okay, so let's say that this is a 40-degree angle. Well, that's the acute part. But we're interested in this back side of the angle, and this back side of the angle is well, it's 360 for the circle. It's 360, so 360 minus 40 would give you a 320-degree angle. 320. So the reflex on that is 320, but it's the back side of an angle. That's the easiest way to describe that. Okay, and the last one is what's called an oblique angle. And an oblique angle is anything other than, remember, because I told you this a second ago. I said it can't be 0, it can't be 90. Like uh, an acute can't be 0, an acute can't be 90. An oblique, an obtuse can't be 180. Okay, so here's an oblique angle. Anything other than 0, 90, 180, 270, or 360. It can't be any of those. If it lands on those, actually have another name that we'll get to in trigonometry, and I don't think we'd really talk about in geometry, but I'll just throw it out there because I know you guys like to learn new things. Those are called quadrantal angles. The 0, 90, 180, 270, and 360 are called quadrantal. And so they have another name and they have other functions in trigonometry. When we get there, you'll learn all that stuff. But oblique angles are anything other than those quadrantal angles. Okay? All right. Well, that's all I got for you today in this lesson. So I hope you have a good rest of the day, and we'll see you later. Bye bye.